All right. So thank you all for joining on this evening, afternoon, morning. It's early morning for me, but it's always great to connect. So thank you all for being here. Super excited. So today I wanted to talk about some career pathways in AI and what are the trends that's happening in academia, industry, and entrepreneurship, specifically because I've been in all three of them. So I can talk about my experiences. I can talk about what is it that I'm working on right now, and what are some of the trends that I'm noticing. So if you have questions about any one specifically, or even my own journey, I'm more than happy to help out. All right, so let me start with a little background about myself, my career journey so far. So I was born in Jamshedpur, and from there, Steel City, went on to BIT Mesta. Again, 4 wonderful years. Like I mentioned, great mentorship of seniors, faculty, everybody, so that I could nurture myself to do my higher studies in the US. Back in 2008, I got the opportunity to come to US for my master's thesis. So now, Vishal did mention that I was working with Dr. J.S. Roy, and I really thought he was fabulous, one of the best professors at that time. So I was working on communication systems. So it was N persistent and P persistent CSMA. I thought, communications was my place, and I wanted to do my master's in it. But what happened is when I came to US, I understood things are not that easy. You don't just choose your domain, a domain chooses you. And at that time, that was 2008, where there was the crash bubble in the number of jobs. They had reduced significantly, funding had reduced significantly. The only place that I could secure funding was epidemiology. And epidemiology in Kansas, it's actually an epicenter of animal and plant pathology research. At that time, H1N1 was also raging. So we were actually one of the first teams to do surveys as well as to publish papers on how epidemiological networks actually spread. Now that's super relevant even to the world today in the pandemic. But there were 2 key findings we found, which I think is very relevant today as well. First off, we saw that we tried to figure out where is it that the disease spreads most. And we found 2 locations. One was children's playgrounds, because they are the people who are least likely to think about making sure that their hands are washed and hands are clean. And the second one was a gas station, so petrol pump, if you may, because that's where you're not really thinking of sanitizing your hands even after you've pumped your gas. So these were the 2 places which we had requested the city of Kansas to shut down, so that the swine flu at that time would have been contained. So think about it even now, so that you understand how you can contain these very epidemiological spreads. Now, I did my master's on epidemiology, and I thought maybe that would be something computational biology or, computational mechanics could be something for my PhD. But again, fate had different plans. I got an option to get a 4-year fellowship, and I went straight to Minnesota. And in Minnesota, my professor was doing digital signal processing, but the funding came from an eye doctor, so an ophthalmologist. So I did my PhD in applied ophthalmology and machine learning for applied ophthalmology. So what we were doing is, again, these are called fundus images and OCT images. We had like several of them. Our goal was to detect pathology, who has how much pathology. And once the degree of pathology, you can then make sure that the more severe people see the doctor first, the lesser one, after that. So resourcefulness of the medical system. So that is what my PhD was. Once I finished that, I went straight into faculty. So right from PhD, I became an assistant professor at University of Washington campus. And at that point, I was working with the School of Medicine, so more on CT and MRI images. But what we were trying to do is get the qualitative, so the technicians' work, in order to make sure the quality of the images is good quality. We wanted to reduce that as much as possible. So bring some automation to acquisition system itself. So that's the CT and MRI images. And that is where because again, Washington, it's the hub of where, Microsoft is. That's where I was able to secure a lot of funding from Microsoft Azure, because that was the push at that time. So Microsoft Azure Machine Learning Studio, that is where I started working more on the deep learning parts of it. Some of my projects were on hyperparameterization. So if you have so many different machine learning models to choose from, how can you ensure, without actually going into the nitty-gritty and doing parameterization, how can you automatically ensure that a model will be best parametrically, whenever you have your test data available? So working more to make biologists and medical professionals' lives a little bit easier. So that's when I started migrating to the cloud. Then back in 2017, I actually moved to the Bay Area, to the Silicon Valley, started at autonomous drive at Google Cars. And again, here there was, autonomous drive, pedestrian intention detection, anything to do to make the car smarter. And then we also switched into Luminar, so different kind of, perception systems, so that, you can detect your pedestrians even at night as far away as 200, 250 meters as well. And that's where I decided to again go back to school. So that's when I went to Berkeley to do my mini MBA. So I'm a Cal grad, and my mini MBA, again, my special topic of my project was autonomous drive, painting the landscape of autonomous driving in future. But that's probably the idea from where I got into the idea of entrepreneurship. So in August of 2020, we were 5 people. We came together. We launched our own company. It's called Fourth Brain. It is still fully functional. It's used to upskill people in machine learning and AI. So till date, over 200 students graduated. So it was machine learning engineering as well as MLOps. So if you want to be more applied, or if you want to be more, novel right from, right from the get-go, that's what we were doing, shorter programs, and all of this was virtual. While I was doing that, I generated my own brand. It's called AI with Sohini. Again, it's a YouTube channel. Please do check out. We do short videos from time to time. Again, based off of whatever I'm working, what's happening in the field, and again, more so to provide the mentorship to the community as much as possible. And right now, I'm in Accenture, and the last picture is that of my son. I'm a proud mother of a 3-year-old, and so the journey continues. One aspect I will say is, right now the industry, at least for the machine learning and AI community, most of it, there's this huge, push towards sustainability. That means don't just use your computers because you are just, your carbon footprint is too high. So think about migrating to, cloud specific solutions, cloud specific environments where you can scale your performances as well as being sustainable, in the process as much as possible. So Microsoft, AWS, GCP, all have taken, steps in that particular direction. Any questions about the landscape? The reason why I wanted to paint the picture here is to say that you will see a lot of risky moves throughout my career, be it coming here or going for switching from academia to industry to entrepreneurship and then back to industry. There's been a lot of risky moves, but I've taken them nonetheless. And all of that has made me understand and appreciate the nuances of each and every one of them. So any questions about any one of them, I'm happy to answer. Are there any questions at this point, Vishal, or should I move on?
There is one question: can electrical engineer become an excellent AI engineer?
Yes, absolutely. Absolutely. So the major thing to get into AI and machine learning is having a minimum understanding of the mathematical frameworks. So if you understand basic mathematics, if you are able to follow logic, then that's all you care about. I've seen aerospace engineers. I have seen operations research. Even as a part of the upskilling business that I was a part of, we had people. So there was this. I always consider him to be one of the success stories. Is he actually is a very successful business. He's doing a Y Combinator for himself. But that student had a background in Spanish. And he was a high school headmaster here, but he had taught himself coding for 2 years. He understood, he could code in Python. He was very good at that. Logic, was good at logic design and mathematics, and then it was just about implementation. So it completely depends what aspect you want to get into. If you want to become a theoretical, artificial intelligence or machine learning scientist, then that's going to require more rigor. But if it's applications, then I believe everybody is doing a minimum amount of applications anyway. So yes, the answer is yes. Anything else before we move on?
One question is coming from Venkateshan. He's asking, I think DevOps integrated with ML in recent job description.
That is true. And that's what I will talk about, is how the landscape of AI and machine learning has actually changed. So I will cover all of that. So let's get ahead then. So I wanted to start with what is AI, so that we think about these in this direction. Now, AI enables people to rethink how we integrate information, analyze data, and use the resulting insights to improve decision making. And all of us, we have seen this now in the recent years, right? So here you can see how the pandemic simulations have worked. And in all of them, in each and every one of them, they have been statistical models, nothing but statistical models where you correlate the, what is the correlation between how many were infected yesterday, how many infected today. There is spread models, so that you can also see, what are the places where people traveled, so that you can start predicting that these are when the peak is going to come up, right? So that is the power of AI, where although, we are in a pickle, but we can get ahead of it. We can start thinking of where it's going to be in a few months, and then, starting getting ahead of the curve altogether. So that is the power of AI. This is another example where AI enables pattern recognition to help identify and characterize unstructured data. So here, this is a typical example of birds of the same feather flock together. So if you have samples of different kind, this is actually handwritten digit recognition. So it's called the MNIST data. And as you can see, all the ones, they start clustering together. All the zeros, they start clustering together. And even if you perturb, your signal in a certain way, this is called a TSNE space. All I'm trying to say is, with the power of AI and machine learning, now you are able to see that, yes, there is an inherent pattern or structure in the data, because of which, it is behaving in a certain way, because of which you can now start predicting. So that is the second contribution of AI. So now you see, it's beautifully, all of the samples of the same kind are together. And finally, AI enables the innovation boom that is around her. Now, everybody knows about a virtual personal assistant. Everybody has tried Siri, or maybe Google Assistant, or visual search engines, real-time translations that allows us for driverless cars. So you can detect pedestrians, you can detect cars, you can make decisions whether you should drive in a particular road or not. We have done weather monitoring, so many fun stuff. It's just bringing everything together so that autonomous drive fully can be realized, maybe in a decade or so. So that is where AI is. It's all about starting from very small tasks, as predicting how many people are going to come online tomorrow, or is the online business going to hit, from e-commerce, manufacturing, finance, marketing, and legal procedures, and even right now, of course, as you see, computer vision, natural language processing, understanding, conversational AI. All of them are deeply moving ahead full speed using AI and machine learning. So let me quickly talk about some of the projects that at least I've been a part of in the past, to give you some ideas as to what are the trends and what is happening in AI in academia. Now, academia is the place where you can do pure research. So it's fundamental, theoretical, or pure research at its core. You don't have to figure about, wait for, clients to tell you, okay, you have a deadline or something. This is where the most of fundamental research happens. And the reason why I'm sharing all of this with you is, when you start thinking of, okay, maybe I need to plan my career journey. Maybe I need to do something else. Maybe you want to do a master's, or you want to do a, PhD later on. You need to start planning ahead. Like, for instance, when I was in BIT, I had already done 2 internships at Indian Statistical Institute in Kolkata. And that was just so that I could get good recommendations letters for my master's. So you need to start planning ahead, and this might give you some ideas as to what other projects you could work on, right? So automated screening for diabetic retinopathy, again, it's a very old, I wouldn't say this is new at all, but again, this might give you some ideas. This is where we are looking at retinal fundus images, and we are trying to classify pathology. So again, looking at an image which is readily available, just a JPEG image, understanding there is compression and there's artifacting possible. But then what we are trying to do is we are trying to make sure that you detect only pathology and not anything else. So we first did an optic disc detection, then blood vessel segmentation, and then we get into the bright lesions, which are your hard exudates, which could also be indicative of diabetic retinopathy, and then detect your the red blood cells or the hemorrhages and the lesions. Now, as you would see that some of these hemorrhages are very hard to even see for us with the naked eye, but the doctors, they are tuned to catch them. An automated system, the beauty of an automated system in medical imaging or in the medical community is it is considered to be a baseline. So it is always going to be repeatable, and it's also always going to have similar performance, unless drastically the operating point or the operating conditions change a lot. So that's the reason why machine learning is definitely utilized in the medical community, because two observers or two specialists may differ in opinion, but typically a specialist and an automated system is always going to behave similarly. It's always going to be a one baseline for sure. The second one was OCT, optical coherence tomography, and this is actually the third layer of your retina. So it's the back of your eye, and it's the third dimension. So that's the reason why you see all of these slices put together. And here, ideally, a normal retina would look like, if they are homogeneous throughout, but then you start seeing these huge cysts that start appearing, and these cysts are actually indicators or biomarkers of DME, diabetic macular edema. So now because we are following where we are doing, and this was just a signal processing mechanism to separate these intraretinal layers. Now you can quickly figure out how much pathology you have, and it can also help localize the exact site of the pathology, so the doctor can know that this is where I need to go in and drain out the fluid, or whatever is the follow-up treatment process there. So again, OCT images also, there are several public domain data sets you can start working on. This was another a self-driven project when I was in Washington, and what this was doing is this was explainability. So because that is another key aspect of machine learning and AI, it's not just having your models, but can you explain why pathology happens? So this was actually a project where we were looking at people who had anemia or not. So if you have your tongue, based off of the color of your tongue, can I figure out if this person is anemic or not? So in this case, as soon as we pass it through a deep dream algorithm, we saw that the inner regions of the tongue and the outer regions of the tongue had different number of segments. So based off of which we figured that there are more features that are at work in the inner part of the tongue than in the outer part. And similar analysis around the eye. So if you're anemic, the doctor will always check your eye. What we found is that the sclera, or the white part of the eye, doesn't have a lot of features, but most of the features are in the conjunctiva, or the underlying part of the eye. So our goal there was to combine the features from both in order to get to a score as to how much anemia every different person has. So feature learning and explainability, extremely important in the ML and AI community. This was another project that we did with Berkeley, and this is on the autonomous drive domain. So here, if you see, this is a typical example from a JAD data set. You see, there are people are being tracked across frames, and that's the reason why there's a tracking ID, associated to every single person. But what we did is we, created skeletal features around every single human being, and we are trying to predict if this person is a threat to the car or not. Are they going to jump in front of the car or not? So if the answer is yes, then the box turns red, and if the answer is no, then it stays green. So the pedestrians who do not pose any threat to the driver, they stay green, and the ones who do, they turn red. So we wanted to do this in a very efficient manner, and I think our paper, we were able to show that we can predict pedestrians' intention up to 30 seconds in advance, so that you know to pause, how to stop, so that you don't hit anyone per se. So some of the examples, and we've been able to show this on poor weather, bad weather as well. So that was all AI and ML in academia. Now let's move on to AI/ML in industry, right? Now, one of the big pushes that I'm noticing in industry right now is the thought to ethical AI and responsible AI. And if you go about, so all of the cloud providers, Microsoft, Amazon, and Google, they have provided their own research, upcoming research, and also the work they are doing in the field of responsible AI. Now, the three components of a responsible AI system is it should be free from bias, it should be explainable, and it should be contextual. Now, let me try to explain what each and every one of these three are. Free from bias means there's a lot of times in which the samples are not acquired in the right fashion. So you may have left someone out. Maybe somebody was absent on that day. So just think about, you went to class someday and you took attendance. Is that attendance really representative of everybody who's paying attention in class? The answer is no, right? There could have been somebody who was ill, who didn't come to class, or maybe somebody went to the restroom. So just coming and taking attendance is not equivalent to how attentive every single person is. So if you're trying to correlate attentiveness based off of just attention, then that's not going to be the right machine learning or AI models. It is written with bias, and that bias needs to be clarified. Explainability, just like I mentioned. So can you explain that there is a high amount of correlation between attendance and being attentive in class? And if the answer is no, then those typical models should typically not be used. So that is one reason why statistical machine learning models are still considered to be superior to generalized than deep learning models in industry, because typically deep learning models are black boxes. It's very hard to explain them. And what happens is sometimes if it stops performing, you don't really know what happened. Why did it stop performing? So that's the one reason why explainability is super important. And contextual is maybe you didn't come to class because something XYZ happened. So just dinging somebody based off of saying that no, you did not come to class, you're not gonna do well in exams, that is an inaccurate, it's a false statement. Just because of the fact that that maybe that student is hardworking, just something happened and he could not come for class. So contextual is taking the prior information, taking the history, understanding the full history before making a decision. So all of these three components, super important. Some of the common biases. Now I'm talking about bias and responsible AI as soon as I'm talking about industry, you may see, because in academia, you can just create an algorithm and forget about it, right? You published a paper, you're done. In industry, you have to make sure that it becomes a product. Otherwise, you don't have an industry, right? So that is the reason why now we start thinking at taking things to scale, so that now we can understand how we can actually productify an AI or a machine learning algorithm rather than just creating a demo. The first one is a selection bias. So in this case, if you have representation errors, a very common example for this is census. Every time, every single state or county here, we are asked to go online and say how many people in my household and income and blah blah blah, all of that. Rarely people fill it out. Now what happens is let's say that the county is supposed to get a certain amount of money from the government because it was the data was not properly represented. It may just assume that only rich people exist in a particular area, and the people with moderate means of living, they don't. Now that is false, right? But based off of that, your machine learning algorithm, that's what it learns. So solution in that case is to detect outliers, to understand, was there somebody left out? And if you have just have one sample corresponding to a lower economical background, then in that case you might have to boost it so that you can oversample the undersampled class, so that you have a good representation of your data altogether. Then there is sampling bias. So one example of this is Amazon reviews, product reviews. So typically it's a human nature. If we really hate something, we will go to a portal and write about it. But if we really like something, we typically like to forget about it. So if you go to Amazon and if you create a sentiment recognition software that is going through all the reviews and saying that it's positive or negative, you will see most of the products there are negative because people got angry, and that's the reason why they went and took the time to write a review anyways. But that's actually not the full picture. So that's the reason why in these cases feature engineering was a better solution, having a thumbs up or a thumbs down or star rating even for your Netflix movie. So making sure you don't just go by the comments or what people have written, but also have another way of figuring out the positive aspects of a product as well. Group attribution bias, it's extremely common, and this is a sort of unconscious bias every single one of us has. So group attribution bias is when a bias occurs when a sample or people belong to a particular community. So let's say I'm a manager and I've asked my recruiter to look for people from BIT, from IIT, from the top institutions only with a certain grade point. So if you have an 8 GPA and only if you have if you come from these universities, only then should you allow them to have an interview. So this is a typical sort of group attribution bias, and it should not happen. And the reason why this should not happen, there could be somebody who has done exceptionally well from another university which was not a part of this group, and they have done Kaggle contests, they have mastery over coding, they have published papers. There is no reason why they should not have been given an interview. But here, if the automated screening process was an automated system, it would probably just go rule-based, and in rule-based, it would end up in error. So in this case, the solution is contextual learning underlying that it's not just the school and the grades is what is telling you how good a candidate is, but actually looking at what else this person has done. So that context is going to help get the right candidate if you're using AI and machine learning for this process. So there's a great course by Google for machine learning users. I highly recommend people go check that out. Now I wanted to show you some examples where AI did not work, so that you will understand what not to do if you're trying to create an industrial product. Now, one of this example, this is actually a ball, tracking. So what happened was the club in Ireland, what they wanted to do is they wanted to make sure that they have a camera that can automatically pan out, and they wanted to make sure the ball is always in the center of the frame. So that way, if there is a foul or not, you'll always be able to figure out. So the model was tracked or trained to detect or to move the head in order to detect the ball only. But what happened is they did not cater to the fact that it also confuses the ball with the bald head of the coach. So you will see that in this case, instead of focusing on the ball, the camera pans out to the bald head of the coach. So in this case, this whole system is riddled with bias. It should have been, given some other examples of what cannot be a ball as well. So it's not just important to say this is a ball and explain it in the regions of interest, but also what is not a football, right, in this case. So that is the reason why systems like this failed. Now, there are the two very recent, systems again we should learn from. Is first of all, it's called Proctorio. I'm not sure if all of you are aware of it. So Proctorio, again, it came to life when everybody switched to virtual, learning. So what this software does is it's supposed to be a software that students install on their computer, and when people are taking a test, this monitors eye gaze, it monitors the number of mouse clicks, it monitors your head movements in order to say that is a person engaged or not, or if they're trying to cheat or not. But in this case, the proctor, when they were designing the system, first off, they completely missed the fact that there could be students who do not have one room dedicated to themselves to take a test. So the lower economic background students, where there are parents coming in and out the room, it was saying that these students are trying to cheat, and it was trying to throw them out. Also, there was skin color, based off of it was not able to even look or track students of certain skin color. So it was riddled with bias, and that's constantly going on. But it just shows that it is not well trained in order to, and you need more contextual learning, explainability, and freedom from bias for such a system to work. The other example is actually the UK grading system. So this is back in 2020 when most of the students had to stay home. They could not take the final exams, right? So what happened was, based off of their mock exam scores and the region where the school was hosted, what the UK government did is they extrapolated the scores for their final 12th grade exam, if you may. And in that case, what happened, 40% of the scores were significantly reduced to what they were supposed to be. And that is because they said, okay, I'm just going based off of the general aggregated scores for that particular school, and also general aggregated performance for every single person. Now, that was wrong. There could have been one person or a few people in that particular school who could have done very well, or maybe they didn't perform well in the mock test, but they were prepared for this particular test. So that's the reason why it was highly ridiculed, because 40% of the students, their scores were reduced. So things like this always have bias. We need to learn from them and make sure that we reduce their bias as much as possible. Any questions so far in the academia as well as in the industrial sector?
Yes, ma'am.
Yes.
Musaddir Hussain is asking whether AI is new electricity or not.
I think they're quoting Andrew Ng. Of course, it is. So, and I think you have to understand the context. So this is good. You have to understand the context. AI is the new electricity. When Andrew said that, it meant that when electricity came in, when humans, when we invented electricity, it was a paradigm shift. It was life before electricity and life after electricity, right? But right now, AI is supposed to be the same paradigm shifter. So there's life before AI and life after AI. But electricity did it much faster. It was like one day, everybody started using it, and then now we are all in the light, right? So even I have the light on. But is it going to be the same pace? Probably not. It's going to be a little, the curve of people adopting it is going to be a little different. But yes, it just means that it's a new paradigm shift, and I absolutely believe that yes, it is going to be that. All right, now let's look at the startup landscape. Any other questions?
Yes, Sohini. Venkatesh is asking roadmap for medical or ML engineer and any recent website, medical data sets or resources.
Yes, there are several, and I will cover all of them towards the end whenever I close up with the different tips in and around. But I always do see that whenever I'm looking at a new data set that I'm interested in, Kaggle houses so many of them, and if not inside Kaggle, they will definitely have the link. The other conference, the major conferences, they always have these special sessions. So MICCAI is a very key conference to follow. MICCAI, MICCAI, as well as ISB. These are very key. There is ISB, there is ISIP. These are the major conferences that do a lot of competitions, student competitions. And because of the student competitions, they release public data set. And most of them are very, cutting edge. Right now, I do see the trend towards more virtual reality or augmented reality towards even medical, images. So that if a surgeon has a, particular glasses on, you can literally see, what areas you are working around. So it comes augmented on top of the video just because of your glasses. So augmented reality is definitely one way of a technology shift. So follow the big conferences. If there is any latest data, it's going to get released in the bigger conferences. Okay, so let's move on to the startup landscape, and then we'll take questions. So for startups right now, and this is in line with what my Venkatesan said, is that's what the research showed, is most of the startups right now are working on ops, taking machine learning and operationalizing it so that you can quickly get products off the door. And the interesting fact is, MLOps is something that is happening more in startups rather than in larger companies. Why? Because larger companies figured out, okay, we already have our products, we already have our clients, we already have things to get out the door. If it's something so experimental, let us wait for the startups to get big enough, and we will just go ahead and acquire them. That's what the larger companies, how they operate. So that is the reason why most of the work around ops, machine learning, operationalizing any of the machine learning and AI systems, it's actually happening at the startup, at the entrepreneurial level. So if you think about this, is all the different fragments that's required to take a machine learning algorithm and take it to production. Right, so there is configuration, there's automation, feature engineering, all of that falls under a data pipeline. So if you're a data engineer, or if you have curated data lakes, data warehouses, then this is definitely one idea for a data pipeline startup company that you can think of. Then definitely there are some startups more geared towards the model pipeline. So let's say that you have 3,600 different models that is getting generated. And when I say 3,600 different models, I believe very small changes in neuron structure or hyperparameters is a new model. So this is some of the problems that Aricto is working. So Kubeflow, they say, okay, it's about in every 14 days there are about 3,000 models. How do you pick which one is the best one? How do you version them so that it keeps getting reused over and over again? And then there is deployment pipeline. So that means where you've taken the machine learning algorithm, you've served it to a customer, but you have to monitor it so that if there is any drift, if it stops performing, you figure that out. And then some of the startup companies are actually focusing more, just on how the monitoring should be done in the proper graffiti or the different dashboards that can be painted and monitored in those cases. So these are the three areas in which machine learning based systems or machine learning startups are slowly starting to come in. Some of the recent focus: importance to innovation over invention. Now, these two are very key words actually, and they're commonly misunderstood. Innovation means you have existing building models. You're not creating the wheel from scratch. It means, can I take an existing wheel? Can I put other components to it and create a machinery out of it as fast as possible? And invention is where you go back to the drawing board, you create a new algorithm, and then you think about what do you want to do with it? Do you want to productionalize it or not? So for startups, now the focus is more getting things out the door. So can you prioritize innovation over invention? And some ways to do that is, the Hugging Face community, the TensorFlow Hub, Stack Overflow. Every software engineer or anybody who's written code ever in their life has used Stack Overflow, right? So these are communities to be a part of, to take advantage of in order to prioritize innovation over invention. MLOps for productionization. Productization is super important. So right now, understanding where is your finesse. Do you want to stick with the data pipeline, work more on the data engineering side of it so that you can ensure the features that go into the model is the best one? Or do you want to work more on the deployment, Kubernetes, Kubeflow, all of that? Or you want to stay maybe in a machine learning studio where you're parameterizing the way like a SageMaker in AWS, then those are some of the areas that you need to focus in. And finally, in the edtech market, and this is exactly what I was doing, right? So it was upskilling people for machine learning and AI. The other kind of edtech market is for job recommenders. How can you match particular resumes to particular skills? So interviews, how to make sure that you crack the interviews. So there's a lot of edtech companies coming up just to make sure that the people are ready for AI/ML jobs, and also they are matched to the right AI/ML job of their interest, right? So these are the three focuses that come up. Now, I just wanted to look at some of the current and open roles and trends before I get into my final tips of the trade. First off is for current open role trends, just as Venkatesan asked, I do see that there is a huge importance of machine learning and AI in the medical realm right now, but it is not very much in the demo state anymore. It is something that is going to scale over time. So it doesn't really matter if you change your model. Maybe yesterday you were working on one version of random forest, maybe tomorrow you're working on another version of maybe graded boosting trees. It is completely fine to do that, but you should be able to scale your model seamlessly as possible, because think about, your end user is not going to be a machine learning expert. So how can you make systems that are robust to that? I definitely see a lot of jobs still around data science, machine learning, and AI, but not just in the software world. But I do see that this learning and engagement is becoming super relevant even in contract generation, in marketing. So if you're somebody who's generating marketing campaigns, how do you know if you can get a better visual or not? So visual search engines, can you use use an exposed API to do those visual searches? So Adobe is doing great research in that particular domain. So there is a huge market for applying data science and AI to all of the other regions as well. It's not just computer vision or NLP. AR, VR, like I said, augmented reality, virtual reality, computer vision applications is again super hot, still going on, right? Conversational AI is definitely caught up more speed in the past few years, I would say, since PyTorch, the whole the framework was launched. So this is where you are trying to get your chatbots as better as possible. So think about any virtual assistant you've ever used, or any chatbot where you said, can I help you? And you typed in a question. All of that is a part of your conversational AI, where a question goes in and the system tries to figure out who is the best person to answer that without getting a human intervention as much as possible. So anything to do around conversational AI and chatbots is super hot and relevant in the field right now. Recommendation engine, it has been important. It is going to keep staying important, because that's what it tells you is what movies to watch, what jobs should you apply for, where should your next track be. It could be in entertainment, sports, whatever it may be. Everybody of us uses Amazon for shopping, or any virtual platform for shopping right now. Recommendation engine is absolutely the backbone of things like that. So how do you make sure that even if it's a new client, you start giving them, recommending products for them without even knowing enough about them already? And then productizations. Don't just think about building a new model anymore. That time has passed. That was like a few years back. Right now the focus is how can you make better products and make sure that they scale. The number of people who are using that product, if it goes from 10 to 100 to 1,000 to 10,000 over a week, you should be able to scale that. So that is something where the push is significantly right now. And just as someone mentioned, engineers with ops background. Ops means your capability to operationalize. So starting from the data, pulling it to the machine learning model and pushing it to the deployment pipeline to ensure that this whole cycle is constantly repeating. So that is operationalizing, so that nothing breakdowns. You have thought about all the different building blocks. So engineers with ops background are extremely relevant to the industry right now. So just knowing your machine learning models is not enough. You need to know something about ops so that you have one leg up over your other competing fellow people who are applying for the job. Finally, some tips and suggestions for careers in AI. Update your LinkedIn and resume every 6 months. It is super relevant. If you are in engineering college, if you are studying, if you are in industry, whatever you do, every 6 months, even if you need to put a alarm somewhere that you need to sit down, update your LinkedIn, make it as clear as what you are doing, your task, your duties and everything. Because it's not just about job finding anymore. It's about networking, finding the right mentors, getting connected to the right people who have the same mindset. So it's about your growth from the comfort of your home. So it's very important that you update your LinkedIn and resume if you're sharing that on LinkedIn as well. Look for aspirational roles. So it's not just what I can do, but I want to do. So, one common job interview question used to be, where do you see yourself in 5 years? Nobody asks that question anymore because it is old date. It has been phased out. Everybody aspires to be someone. Everybody aspires to, in the next few years, we want to do something. So based off of that, create your LinkedIn community, or, create your, community around you, be it GitHub, Kaggle, whatever it is. Make sure that you have aspirational models and you start connecting with them. Keep current on trends, on research trends and papers. One way to do that is if you feel you belong to the medical community, then look for the top conferences, and again, what are the papers that get published there. Sometimes if you don't have access, then check if the similar paper is there in archive or not. Archive makes life a lot easier for us, right? But don't just read any paper on archive. If it is something that has been accepted at a well published conference, then only try to read and replicate it and make it better. Even network for mentors. Now this is something that I have personally started doing over the last few years a lot on LinkedIn, is finding a little bit of time and mentors. So sometimes if people are stuck maybe, and it can be for 1 gazillion reasons right now, but look for mentors, look for guidance, look for advice, be it on LinkedIn, Instagram, wherever you're looking for it. So don't sit in a silo. If you sit in a silo, there is nobody to help you get out of it. Especially in the virtual world, you're at home, nobody can see your face, nobody understands that you're going through a tough time. So don't sit in a silo, speak about it, speak out, and reach out for the mentors. I'm sure at this time, the world is more compassionate, so nobody's going to say, no, I'm not going to help you. Maybe they say, okay, I'm busy right now. Can you come back later? Or in that case, you can ask, okay, can you tell me about someone else who can help me out right now? So building a community, and that is one thing that I've been trying to do with my YouTube channel as well. So building the community, asking questions, connecting people, who have similar interests. So do that, and I'm sure your journey with AI/ML will be successful, Mark. At this point, I will stop sharing and let's get to questions.
Good job,
Yes,
Sohini.
ma'am.
Yes, Akshi, go ahead.
Yes, ma'am. It was a great session. We have one question from Sri Chakra Kumar. He's asking, what's your opinion on NLP methods that are currently available? And he's also asking that whether the NLP at the state of the art enables some applications like asking questions to an ebook and getting an answer to it from a model.
Asking questions to an ebook. Okay, so there are different components to a natural language processing, the whole NLP system. So first of all, let's go break it down into the different components, right? When you ask a question, so the first thing is audio to text. You need to convert it, and then you'll find a lot of embedding softwares in that case as well. So once you have the text, now you're trying to get then it's NER, so entity recognition, sentiment analysis, all of that goes on to the text. So based off of that, then you try to understand what the question was. So that's natural language understanding. And then based off the understanding is so again, by the time you're in natural language understanding, you're again in feature space, you're not in text space anymore. So now based off of that, now most of the question and answer services are mostly rule based. That means if they have seen a question like this before, they know how to answer. Maybe a human has already answered that, so they already have sort of a an indexed hash map, if you may, where it says, okay, this one was the last time a question like this was asked, so this was the answer. So that is the most common way things are going right now. But if you now have an AI, that means it should automatically learn or automatically understand and get better with time. So it's a reinforcement model in that case. So reinforcement learning, it learns in a very human-like way. So if I've been asked the same question in two different types, the human understands. So that means these both things are the same question, right? Even if you're asking to an ebook. So that part, the reinforcement learning part of the AI, that is still under development. So that has still not been perfected yet. Typically, it is still the goal that if you've seen something before, it's more supervised machine learning. If you've seen something before, it's on the similar lines, you will just connect it to it. However, if your memory can grow significantly, and this is what AIOps from IBM Research Lab has done, if the memory is significant, somebody probably has asked that question. So it is very rare that you come up with one unique question that nobody has asked before. And if such a thing happens, in that case, you'll probably get to the next best answer for this particular case. So now we've got natural language understanding, and then comes the process of natural language generation. That means once the question is answered, once the question is asked, then an answer gets generated. And that answer, first it is generated in the feature space, then a text gets generated corresponding to it, and then again, if you have a text to speech converter at the end, then that voice comes off. So that is the way in which you interact with your virtual assistants, right? Siri, tell me a joke or something like that. But Siri already knows some of the questions that's been asked, and if you sometimes stump Siri with something very unique, what's the I think I've asked a few questions to Siri, like that. If you ask, what are all the planets in the solar system? She'll probably say, oh, I don't know that. And that's the reason for that. So in those cases, if there's a question that's not similar in nature, it will be stumped. But right now, the focus is in understanding or generating that reinforcement learning background that takes the natural language understanding to natural language generation. So NLU to NLG. I hope that answered the question.
Yes, wonderful, sir. Sohini, next question is being asked by Satyajit Mahapatra, a PhD scholar in our department. He's asking, gradient vanishing is one of the major concerns in designing a deep neural network.
Yeah.
How to compute the gradient of each layer using Keras or TensorFlow?
So gradient vanishing is definite. So gradient explosion and gradient vanishing. These are both very key problems in deep learning aspects. When you are saying that, are you trying to compute them in Keras? Ideally, Keras is a better way in which you can actually see what's happening in every single layer. This is actually a very good interview question. I ask this question a lot. How would you go about making sure that your model is free? And just to give you an example of how you can figure out that gradient vanishing has happened, is you have a model which is pre-trained. Let's say it's doing bounding box detection. So you have your historical data in, you see the bounding boxes. Now as soon as you get new data in, blank images, nothing is coming out anymore. And that's where that maybe something became not a number, or maybe just things just went out of scale. So in these cases, there are several ways to deal with the gradient vanishing problem. First off, you should always look at least this is what I do, is I always dial back to the data and see, is there some rounding errors, or maybe I was doing a divide by zero error, which drove everything to a zero or not a number to begin with. So then those should be caught in the data side. As for the for the next layers, this is the reason why residual layers or residual resnets, residual models came up. Because residual models, there, if you think about signal processing, the goal is you take the signals that was working in the previous state and you amplify it. So you boost the signal strength at a particular layer based off of what was happening maybe a few layers back. And that's the reason why dense nets, where you have immense connections from the previous residual layers, they have actually showed to scale much better. But again, the computational complexity is much high. So if you have enough GPU access, if you have enough memory access, then going the residual network route is actually a better option. And there you can literally pan out every single layer if you're working with Keras, and you can look at every single layer and understand that this was the one where your weights actually went off. I hope that answers, and I hope you remember this so that whenever it's asked in your interview, you know how to answer it.
Yeah,
that must have answered the question, ma'am. One more question we have from the comment section. It's Venkatesan again. He thinks that DevOps has more jobs in ML in 2022 than ML in 2022. So he's asking your opinion. What do you think?
It is true. And I wouldn't say only DevOps, because it is more getting machine learning along with the ops background. Now DevOps, it was the older job description, I would say. And whenever you were doing DevOps, you were supposed to understand all about the data, all the different, Redshift versus, Ruby on Rails. So all of those, all of those were super relevant. But right now, you're even if you're saying DevOps, it's not just about taking the simplest model to production. It is actually taking the machine learning model that's been built to production. I'll give you an example, at least from where industry was at least 5 years back. If there was an R&D team, they were creating these very cool object detectors, or they were creating this very cool models. They were showing a demo, and that was it. Okay, and they say, okay, I'm done with my demo. I'm leaving. And now the DevOps people would come and say, okay, this is too complicated. I cannot operationalize it. I don't even understand this model. Let me go back to something which is rule based and easy for me to understand, and that is what I'm going to operationalize. So this is where the industry was a few years back, where AI was just a cool demo, but not an important thing to have. But now that we are thinking of taking things to scale, it has become super important to understand machine learning along with ops. So just DevOps, I wouldn't say is the hottest market, but it's machine learning along with the ops, data along with the ops. I would say there is a higher volume for jobs in the market.
That must have answered this question, ma'am. There are some questions from a sheet we circulated along with the webinar link.
Mm-hmm.
So one question is, what skill sets are essential to build ourselves for policy development for AI roles?
So policy is, and this is actually a very key topic right now in industries, and every single industry is taking a different stance at it. So right now, AI is still in the human assistive mode. What that means is you still expect the AI to give you back some results, but the decisions as what is to be done as the next step should always be taken by the human. So the simple guidelines that are in and around industry policies or industry standards around policies is, first off, a human life should not be harmed in any way. That is a super important rule of thumb. And the second is the amount of involvement of a human in this in building this AI system should be at least as much as one human being in the loop as you can trust in a fully assistive expert system. So what that means is, maybe the example that I gave you, right? So you have an ebook, you're trying to understand natural language processing and natural language generation. Maybe the reinforcement learning at the back end was just a human. So a human was telling, okay, this one was the question, I think this should be the answer. So that is one way. And then it becomes an expert system who learn from that and say, okay, now if this was the question, this is the answer. So at least your expert should be, even if you're creating an expert system, it should be at least as good as the human in the loop. Otherwise, there should always be a human in the loop. So AI is still working in the assistive mode. It is not, taken charge, and it's not freewheeling or free running yet. So there are guidelines and policies, just as around data, GDPR guidelines were created so that data sharing can be optimized and data sharing can be controlled. In the same way, AI and the usage of AI for innovation is currently, every single company is taking their own stance at it. So I'm sure in the next few years we will see conglomerated policies in and around a lot of them. I hope that answers the question.
Yes, ma'am. One more interesting question we have. It's asking that can we enhance our brain capabilities by using AI tech, or can we use AI tech to make artificial trees?
Artificial trees? You mean trees or decision trees?
Trees, ma'am.
Okay, this is going very deep. Now, first off is, so reinforcement learning is one phase, is one aspect of machine learning and artificial intelligence. That is the most human-like way of learning, right? And what we say is, it makes a mistake once, it gets a feedback, tries to get better every single time. The human brain also works the same way. If you are, and that's how we grasp knowledge. So that's the whole cognition, whole research around cognitive systems, the whole research around knowledge discovery from databases. The more you learn, some you absorb, some you don't, right? The next time probably you absorb a little bit more, and then a little bit more, and so on and so forth. So yes, there is a way to train our brain, and the way to train our brain is to not take huge leaps and bounds. So think about it. If you're an engineering student in the first year, if you started taking the final year courses that the following semester, is probably not going to register. And that's the reason why you have 8 semesters. You go from one to the second, to the second, to the second. And this is the reason why there's always continuity. Whenever we create courses, there's always a prerequisite and what you can do after that, right? So the way to train is to make smaller adjustment to the knowledge learning, to be able to assess yourself. That's the reason why you have exams. To take short assessments. Did I learn? If not, then maybe I need to repeat maybe this lesson before I go on to the next one. It's the same thing when we do, learn a new language. You learn short words, then you start putting sentences together, and then you understand grammar, sentiment, and all of that comes towards the end. So it's always understanding what is the delta that you need to cover so that you can start, building towards it. And coming to artificial trees, and that's more of a biological research, I would say. Why not? But I'm not aware of anything like that at the moment.
There's another question, ma'am. What someone is asking, what kind of job opportunities are there for UG students in this field, and how to start their career in ML and AI after BTech?
Yeah, so that was actually something that I was talking about from my career journey, right? So start early. I can tell you from my own experiences, when I started thinking about, I want to do an MS at the end of my bachelor's. I started planning at the end of my second year. So at the end of fourth semester, I started thinking about it. I got all of the prep materials to get my GRE and TOEFL score squared away. But more important to that is I knew that you require recommendation letters from eminent faculty members to make sure that you get through and even get some funding in the process. So I was able to come to US only because I got funding. Otherwise, there was no way I could have supported myself. And that's one reason I worked even for 1 year in India to get the money to even apply, because it was that expensive, right? The dollar to rupee ratio. So in that case, start early. At the end of the second year, what I did is I started applying for academic internships. So I got accepted to Indian Statistical Institute, Kolkata. I worked with this faculty, wonderful. She guided me through the whole process of taking a physical system and creating computer models around simulating VLSI chips, essentially. So that was something that I did for 2 summers and one winter. And so she wrote a stellar letter for me. I had a great project to show for. I had my GRE squares, score squared away, so I could come for my master's. Now, if you're talking about a job at the end of it, then just being aware of all of this, maybe start your GitHub as soon as possible. Make sure you polish your, LinkedIn. Make sure your GitHubs are not just one line in the README. It has a proper well-built README that people will be using. Kaggle contests, take the contest, apply the data, do something which is beyond the lines in your resume, the special achievement section. Try to fill that, and it doesn't just have to be awards and recognitions. It can always be, this many number of times you were on the scoreboard for this particular competition. So this is where you participate. And in your job interviews, you can even talk about if there were a couple of people who came together to participate in a coding challenge. You can say that you've collaborated, because every company wants to hear, are you a team player or not? So that way you've already shown that you have the technical skills, as well as you collaborated with people on projects. So a win-win in either case. So if you want to pursue your studies after that, plan ahead. If you want to plan for a job, make sure that your code base, it's not just important anymore to have a resume. You should have a resume, you have a LinkedIn, and at least you should have a GitHub profile with a few good repositories to show for, because all hiring managers go back there. So for anybody who I ever hired, I always checked if they have a GitHub profile or not, and very well built repositories or not. If they didn't, I didn't hire them. So that's again super important trend. It's not just your resume anymore, but GitHub is equally important.
It was great, Sohini. Definitely, it was a very wonderful tips. And I'm sure the listeners will definitely look into their LinkedIn profile, their GitHub scores and all, because these are one things which you students, I'm yet to explore everything on GitHub, though I'm very much prominent, very active on LinkedIn. But still, your tips are better, and I'll also try to incorporate this into my resume also, because though I don't want to change, but it always gives a pleasure if you have a better resume there.
Yeah, absolutely. And now connections, maybe you can be mentors to people who are aspiring to be you, or people are stuck in a place, but because you have more details in LinkedIn will start recommending you to other people to reach out to you. So it's not just necessary that you reach out to people, others can reach out to you as well.
So will you be able to give some sessions sometimes how to manage GitHub and how to manage LinkedIn?
Yes, absolutely. Actually, I have something like this on my channel already. So there was that's what I started with right at the beginning, is what are the things that you need to make sure that your GitHub and your LinkedIn profiles are as good. So maybe I'll share the link with you. You can share that with the students.
Please. And probably because now what I'm seeing is there is a lot of buzz in ML and other fields of artificial intelligence. So maybe my student would definitely try to reach out to you for various helps. As I told you last time also, they are looking for good projects, and that always helps. Yeah, so absolutely. Let us forward this journey, because you as a student have always been phenomenal and always ready to help the alma mater. Absolutely. And those who are present over here, I'm sure they will also accept this, that it was a wonderful session, and it will be taken care with. It will be taken to a larger extent now. I'm thankful to you.
Absolutely. My pleasure.
Thank you, Sohini.
We'll close it off.
Sakshi, anything you would like to comment on?
Yes, sir. It was a wonderful session, ma'am. I personally got to learn a lot about artificial intelligence. Thank you so much.
Absolutely.
Sohini, she is my new student for the SARC coordination.
Awesome.
So she is awesome. This is the first session she has managed on her own completely, and I'm thankful to you, Sakshi. Thank you.
Thank you,
Awesome.
sir, for giving me the opportunity.
I can tell you that when we were in the BIT cell, we didn't have the virtual world exist in this much in this much depth. But I can definitely tell you the connections the students are getting through, the digitization is. I can see that already. So it's a great job that you're doing. So thank you for all that you do at BIT SAR.
Thank you.
All right. I will stop the live stream. Thanks, everyone. Please do keep your questions coming. And if there are other questions in chat, I'll be happy to answer them even offline. All right. Have a great night, guys.
Thank you.